basically we have done the procedure, and I'm just going to do this quickly because we don't have a lot of time here. But I'm going to talk about this analysis section, and we're going to talk about this in enough detail you should be able to answer the post-lab questions after that. And then I'm going to explain, I'm going to make sure everyone understands exactly what's expected on the post-lab so that you write this up correctly. Now, this lab is not due until the day after our Unit 1 test, okay? So we take the test. You'll turn in both of your first 2 labs at the same time. So this, you don't have to have this written up right away, okay? But I just want to talk about it now. So we did an experiment. You might not have actually known why you were doing the procedure that you were doing, even though you kind of developed it. But this experiment hopefully showed us something about the identity of that original powder, okay? Well, okay, so we figured out some interesting things about the density of that powder. Or we didn't, depending on how we measured the volume of it. But so let's just think about this for a second. We were trying to figure out what that unknown powder was. Now, we've talked about what the end product was, right? We came to kind of a consensus on what the end product was going to be. What was the end product going to be after the heating? Probably CuO, so copper 2 oxide, right? Okay, so that much we can kind of be confident about, that we ended up with Cu2O, all right? But then we talked about there's 2 scenarios for the beginning reaction, all right? So it could have been Cu plus O2 yields CuO, and again, we'd have to balance that. I'm not going to worry about that right now. Or this could have been maybe Cu2O if this is copper 1 oxide to begin with, plus O2 yields CuO. Either one of those scenarios is plausible, all right? So we've got to figure out which one of those actually occurred. Now, are there any ideas about something we could figure out that might help us with whether it's Cu or Cu2O at the beginning? Okay. The thing is, with both of these, the mass is probably going to go up, right? And I know that looks weird because Cu2O, it looks like the mass would have gone down. Okay, but if you think about it, this is copper 1 oxide, so there's only one. So it takes 2 coppers for every 1 oxygen to make the lattice there, okay? So you got to kind of think about that in terms of an ionic compound. What you're doing when you make CuO is now you are adding oxygen into the lattice, so now it's a 1-to-1 ratio between the copper and the oxygen. I don't know if that makes sense or not. But essentially, you're not decreasing the amount of copper here, really. What you're doing is you're increasing the amount of oxygen to make the CuO, okay? So either way, it's being further oxidized, okay? Well, okay, let's go ahead and balance, and that might help to avoid some confusion here. So 2 here, a 2 here, 2 here, and that's not going to work, is it? We need a 2 here, we need a 4 on the stupid big eraser. 4 CuO and a 2 here, right? Okay, so now maybe you can, huh? Oh, I'm sorry, okay, because it's, yeah, we already had 2 oxygens over there. This is going to be a great video. Okay. So there's our 2 equations, all right, and they're balanced. This is supposed to be a 2. I don't know what happened there. Oh, I erased it. Either way, we're adding oxygen, so the mass should eventually increase. Okay, so that's not going to help us that much, but the amount the mass increased by, that might help us. Okay, so let's think about this for a second. What someone whose mass did increase, tell me your ending mass of the CuO. Okay, 1.1437 grams. Now this is just an example because, everyone's going to have to use their own data here. But that's the mass of the CuO, right? Can we kind of work backwards and figure out how much copper is in that compound? Do you know how to do that? So let's go from grams of copper oxide to moles of copper oxide. And that's going to be, I don't know where my big calculator is. This thing's tiny. $79.5, 79.55 or so for the molar mass. Okay. Then we can go from moles of CuO. We've done this little trick before. To just moles of copper. Okay? And actually it's a 1-to-1 ratio here. But then we can go from moles of copper to grams of copper. And in 1 mole there is 63.55. Okay. Now I'm praying that your data works out. We'll see. 1.1437 divided by 79. I need my calculator, my real calculator. Where is it? The buttons are in a weird place. All right. Anyway, I guess I'll have to use it. .55. Okay, so I'm getting 0.914 something for the mass of the copper. Is that right? All right, now here's where this can help us. What was the original mass of your unknown that you started with? 1.0600. Well, it appears that there was something else in there, doesn't it? You guys see that? Because either one of these reactions, the only thing that's happening is oxygen is being added to the compound, right? So we're not gaining or losing any copper here. Can we agree on that? Okay? So if I figure out how much copper there is in the final product, based on the law of conservation of mass, that's probably how much copper there was in the initial reactant. You guys following? Okay? So if there was 0.914 grams of copper in the initial reactant, but we had 1.0600 grams in the initial reactant, then there was something else besides copper in that initial reactant. Are you following that line of reasoning? Yeah. It is from the product. But again, what I was trying to make clear is when this chemical reaction occurs, the only thing that is happening is that oxygen is being added to the copper. There is no new copper coming in from anywhere, right? So if we figure out how much copper we have in the product, we can assume that's how much copper we had in the reactant as well. Does that make sense? Because there's no other source of copper coming in, okay? So, and this data actually works out okay. I don't know if it's going to work out perfectly when we try to figure out our ratio, but this kind of shows us that maybe this is the more plausible scenario. You guys see that? Okay, and again, that's just sort of thinking about it conceptually, but this wasn't just copper to begin with. This red unidentified powder we had here was probably not just copper. Yes, ma'am? It doesn't matter because of the reaction. Now, if we were doing a reaction where there were copper ions in solution and they were coming out of solution and there was more copper being produced or something like that, then it might matter. But if you look at this reaction, all that's happening is copper is combining with oxygen, either way, or copper oxide is combining with oxygen to make copper 2 oxide. So the amount of copper we have in the final product should equal the amount of copper we have in the beginning. Does that make sense? Oh, okay. So this is just the Cu2 here. The reason that you're going to use the 63.55 grams here for the Cu, this is just an ionic ratio, right? All I'm trying to figure out, I'm actually trying to figure out, and I know this is weird, and I know we didn't really do a problem quite like this last year. We're trying to figure out how much copper there was here, right? How much copper is there here? And actually, once we figure that out, we kind of did do a problem like this last year, right? So if I know this is the amount of copper in the product, that must have been the amount of copper in the reactant just based on the law of conservation of mass, right? Unless we're doing a nuclear reaction, the amount of copper in the product should be the same in grams as the amount of copper in the reactants. Everybody following that? You're looking at me like you're not quite following that. We can talk about it more if you need to, okay? But the main thing I want you to see here is this is the mass of the copper, okay? This is the mass of our initial unknown right here. They're different, okay? This number is higher, so there must have been, and I'm going to assume that there was some oxygen in there to begin with, okay? Well, because we kind of narrowed this down to two possible scenarios, right? If it's not this one, then it's got to be this one. Okay, if it's not just copper in that red powder, then it must be copper 2 oxide. Okay, because those are the two possibilities we sort of narrowed it down to. All right? Again, I know that's conceptually that's a little hard. So, now what we've got to figure out, because I'm not okay with just explaining it conceptually, I kind of want to figure it out mathematically as well. See how close we are here? How could we verify with our numbers here that maybe this actually is Cu2O? Any ideas how we might do that? Okay, and how could we use percent composition for that? Okay, so we know our total mass of the unknown, and we know the mass of the copper, right? So, and if we're assuming the rest of that is oxygen, then we can probably just do an empirical formula calculation at this point and see if it works out to Cu2O, okay? So now I don't know if it's going to or not. I'm using, I'm using actual lab data here, so this may work, it may not, okay? But let me keep these two numbers, yeah. And then I'll erase everything else up here so that I have room to work. I'm just going to write over stuff. I'm sorry, I know that's a little annoying. But this way it records what I'm saying on the video in case you need to go back and watch this later. So we've got 0.914 grams of copper, right? So how many grams of oxygen do we have? I can't do that in my head. I actually probably could do it in my head, but I'm lazy. I don't want to. Come on. This really is not a good calculator. Minus 0.914. It's going to be 0.146, okay? I put those kind of close together. But what's our process here? Figure out empirical formula. Yeah, we already did the percent to mass, or we don't have to worry about the percent to mass part because we've already got the masses. So just mass to mole, divide by small, multiply to a whole, okay? I'm just curious how well this works out, so someone's going to get their lab data worked out for them on a video, which is, yeah, kind of nice for them. Unless I'm doing it wrong on purpose to throw them off. I'm not doing that. That would be really mean. 63.55 and 16. I could do it wrong by accident, though. That could happen. I'm inspired by your confidence. What is wrong with this thing? 0.9? You have to push the button super hard. Divided by... I would. Yes, please. Yeah, anything's better than this. 0.8. Oh, it's pink. Or purple? What is that? Okay, alright. 0.146 divided by 16. 0.009125. Okay, so our smallest number is the bottom one here. This is already boding well for us, but let's see. 125. 1. Okay, not bad. 1.58. In a lab setting, we can round that up to 2, right? I mean, that's about as good as I expected the data to be on this lab, given the amount of time that we had. If you'd had more time to heat it to make sure that you got to constant mass, then you might have been closer to a 1-to-2 ratio. But that's looking pretty good. Okay? Yeah.
Okay. We want the calculations lab.
Yes. So now let's talk about exactly how I want you to write this up. Because I think we've talked about enough that you can kind of show in a quantitative way, this is probably copper 2 oxide. Okay? Come on. You know what? I don't even need to erase that right now. Let me open up your Guide to Acceptable Lab Notebooks, because that's what I want to reference here. If I can find it. Oh, it's not in Unit 1. I know. Only I can figure out where everything is here. Okay, so the parts we have written up so far. We have done what's the beginning question. We've done the background information. That's the pre-lab questions, which there was a video that helped explain those. Okay. How will I conduct the investigation? Which, by the way, those pre-lab questions, I've now embedded them in Moodle. So if you have, it's still not going to work because I had to use YouTube. It's still not going to work in the Chromebooks. But it will work if you have a smartphone, if you have any sort of phone with internet access on it, or if you have an Apple computer. Okay, it should work now, and I'll keep posting the videos that way. How will I conduct the investigation, the actual procedure? You should have written that up before we started the lab, and how will I stay safe? Hopefully you have those sections in there already. Okay. What observations and measurements did I make? You need to figure out a way to organize your data into an easily readable data table. Okay, complete with a title, units, and legible numbers. All right? Legible. I know some of us have a problem with that, okay? I need to be able to read your numbers. All right? And make it organized. If my eyes hurt when I look at it, I might just skip that section and take off points, okay? Don't make my eyes hurt. All right? Then what can I claim? What evidence do I have to support the claim? Okay, so that's your next section. And that would be where you're actually claiming what is the unidentified powder, okay? And that's where you're going to do your calculations and everything like that. Your calculations are going to be part of your evidence, right? So you'll reference back to your data. You'll make calculations that support your claim. Everybody clear on that part? How do my ideas and results compare with others? Okay, at some point you are going to have to look at other people's lab notebooks or at least talk to them and say, hey, did you end up with about that 2-to-1 ratio? I wouldn't worry about the literature on this one, okay? Just compare it with each other and that should be fine. And then, excuse me, how have my ideas changed? The obvious answer on this one would probably be if you thought it was copper to begin with, but now we realize it's copper 1 oxide, that would be a change in your ideas. If you initially thought it was copper 1 oxide, you can say, no, my ideas were actually confirmed here, okay? Or if you had no idea, then your idea changed, right? So does that make sense what's expected on the write-up for the rest of that lab? Okay? Anytime we do an inquiry lab, these are the sections that you want to make sure are there. And just label them very clearly so I can tell what section we're in. You can just rewrite this question if you want, or if you want to shorten it and make this safety, make this observations, measurements, or data, something like that. Claims / evidence, okay? However you want to do it, just make it obvious to me what section we're in. Yes, ma'am? Yeah, it would be good practice for you to use sig figs on your calculations, okay? Because, and in a lab setting, that's actually where sig figs really do matter, right? Because that's when we're making measurements and we don't want our calculations to show a degree of precision that we didn't actually use in the lab, okay? So good question. All right, so that's it for lab number 1. And again, this video will be posted in case you need to go back and reference it while you're doing your post lab, okay?